Today we are going to build an anti-lock solenoid unit bleeder. We have our solenoid pack from the junkyard. We have plug taken off a wrecked Land Rover. We have an oscilloscope for testing signals. We have a flip-flop switch. And we have electronic oscillator. We're going to use the oscillator to power the flip-flop switch. The flip-flop switch can carry a lot more current than this little electronic oscillator. And the solenoid pack is going to draw too much current for our little electronic oscillator. So we're going to use this to control this. This will take all the current that this needs. And what we'll be able to do is inside our truck, we're going to be able to plug in and then use these to cycle our solenoids and get all the air out. Now what we have a couple of little light bulbs as test units. That's our load. We have a little jumper pack with a nice little pigtail as our power supply. And bunch of jumper wires. Got these from Harbor Freight. I got this flip-flop switch off of eBay. Got this oscillator switch off of eBay. The links will be in the description. And I got my little oscilloscope off of eBay. I'll put the link in the description also. This I got from a local junkyard, and this I got from a buddy on Facebook, who is one of many people in a Facebook group of Land Rovers. So we have the power. Right now we're just testing the flip-flop switch, okay? And we have the lights hooked up to a normally open switch. Now this is right now being controlled by my nephew. Say hi.
Hi.
And he's going to hit the switch and the lights should light up. So hit the switch. There we go. Off. Do it a couple of times. Okay, so we know this works. Now we're going to wire this up and have this control this. But this is an AC/DC, so it doesn't matter the polarity. We're lucky. So we feed this side voltage, and it will close this switch, and then when there's no voltage, this switch will be closed. And that is what we're going to use to power our solenoids. Well, now we just tested our flip-flop switch. Now we have our oscillator plugged in. We have main power. Then we have switched power going to our flip-flop switch. And then we have a horn button to give it a signal. The signal is just hitting it with electricity one time. So we're wired into our 12-volt power source. This is all very high tech. You can tell this is a state-of-the-art laboratory with my assistant here. Hello. Hello, assistant.
Hello.
You want to look up and say hi?
No, not really.
Not really? Okay. So let's turn this on. Oops. I'm going to somehow turn it on. Oops. There we go. Okay, so there's a loose connection. No kidding, right? It's a breadboard. What do you want? Once the design works, then I'll solder stuff together, and we won't have just wires plugged into a breadboard. So these units can be programmed in many different modes. I've programmed this oscillator to turn the flip-flop switch on and off every 0.1 seconds for 0.1 seconds on, 0.1 seconds off. So it's what we call a 50% duty cycle. and it should do it 999 times in a row. So let's see what we got. You want to hit the button for us?
Sure.
Okay, come on over here, hit the button. That one right there. Well, now. Looks like it works. Okay, so now our next step is, instead of a light, we take our harness and wire it up as the load. And of course, make sure we have reliable connections, and so that we're not blinking all the time. Yeah, so we have to make sure we have good, reliable connections. So we'll strip out the connectors. There's 4 ground wires, and there are 8 solenoids in the solenoid pack. So we have 8 gray wires. So I'm going to wire this up for the operation to flip-flop between the 4 here, and that way we will be oscillating the solenoids, and we're not putting a tremendous load on our electronics. We're only powering 4 at a time, so when these are on, these are off. And I will wire all of the ground wires together. There, we got them all stripped out. I stripped an extra amount of insulation off the wires so that I have plenty to work with. What I'm going to do is I'm going to plug it into the unit. I'm going to test each solenoid one by one. And I encourage you to do that with your ABS unit, because you may build one of these, and then lo and behold, if you have a bad solenoid, you're not going to be able to get all of your air out of your ABS unit. So do make sure that all of your ABS solenoids do function. I'll show you that in just a moment. You go to test an ABS solenoid. We want to actually feel it click. A lot of people say just do a pinout resistance test. Well, you can do that, and that'll tell you whether or not the coil is good that actuates the solenoid. But it won't tell you if the solenoid is moving. If the solenoid is not moving, you can still have a good coil. It could be jammed for some reason. So you want to actually be able to feel it click, and you'll feel it go tick, 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 tick. And so you want to verify operation of all of your solenoids first on your vehicle. I had to trim some of the plastic off. The junkyard dropped it.
It wasn't putting right.
That's right. So now we can plug this in. There we go. And we have our pigtail. Let me see.
It's falling off.
So we got ground wire to a ground wire. All 4 of the black ground wires on this particular solenoid pack connect inside. So it doesn't matter which one you connect to. So I have my starter button connected to positive. Now, listen to the click. Well, turn it on first. There we go. Now listen up. You can actually feel that. That's how we know solenoid's working. So, on your vehicle, you need to test every single one. Make sure they're working. Alrighty, we have a mock-up here. We have our power, trigger button, our electronic oscillator hooked to a flip-flop switch. Flip-flop switch is powering right now just a single solenoid. So we are going to hit the button and watch everything blow up. Here we go. You can hear that solenoid working. That's what you want to hear. So test all your solenoids one by one, and hook up this little contraption. turn it off. Tell you what, you come around the other side of me, hit that button. Hit that button. Okay, you come on over to the ABS solenoid pack. You tell me, is that thing clicking? Put your ear up to it.
Yeah.
Okay. We're doing 4 at a time here. Here, hit that button again. All right, good job. Oh, get your fingers off. Here we are on the vehicle itself. Here's my anti-lock solenoid and my plug. I've got it wired up to the battery using a starter button to actuate each individual solenoid. So, listen. Gotta do that for every one. Make sure it's operating. Make sure you hear it click. If you can't hear it click, if you cannot hear it click, it's probably stuck. Maybe wrap on this with a hammer, but not too hard because you don't want to break anything. Give it vibration while you're working your button. I've had that free up some of these solenoids before because these trucks will sit for a while and there'll be a little bit of corrosion, a little bit of goo, and maybe some moisture is in the brake fluid, and it makes a kind of very thick, white, creamy substance. It's kind of icky, but it'll stick them closed. And I'll do that for every single one. Make sure they're all working. Well, we finished testing all the solenoids. They all work. So we're going to unplug this plug and plug the factory plug back in for now so I can use it tomorrow. See this real thick round plug? It's got 2 wires. Wires go all the way around to the side of the unit. This is the motor that drives the pump. Okay, it's a high pressure pump. And we're going to hot wire this and we're going to test it. So here we are, hot wired up. Got the negative to the negative, positive to the positive, and our starter button. Now, here's the motor. It should operate smoothly. It should not sound like a belt sander. So let's give it a shot. Hear that? That's a good motor. I'm going to hook our power leads up to the truck, positive to the positive, and we're not going to hook the negative to the negative terminal, because if there happens to produce a spark, then we could blow the battery up in our face. So hold the negative in the one hand while you connect to the positive terminal, and find yourself some screw somewhere. Looky here. That is grounded to the body, and that way this can spark all at once and you're not going to risk blowing up your battery. And when you disconnect them, disconnect your negative first and keep that in your hand, and then disconnect your positive. That way we save your face, you don't get covered in acid, and you get to drive your truck tomorrow. We're going to use this little test lead box. I saved it a few years ago. And we're going to put all the components in here, and let's get started. With the help of glue gun, we've mounted a fuse box for power distribution, and our electronic oscillator, and our flip-flop switch. Now, a lot of people will say that I could have controlled a headlamp relay, a 5-pin headlamp relay with a flasher, and that is true to a certain extent. But we would not be able to really control how fast the solenoids would cycle on and off. This gives us full control. Okay? Just wanted to clear that up. This is the digital way of doing it, whereas the flasher method would be the analog way. Instead of using a flush mount horn button, I'm using a recessed button. This one costs 12 bucks. This one costs like $7. But this fits my design better because it keeps it within the case. Well, we've got it all mounted in the box. A couple of fuses so we don't catch too many things on fire. Got the power coming in, got a main power switch. That's always handy. And this provides power to the circuit board and to our fuse box. And we have our little switch over, little button here to start everything off. And so once we hit the button, the flip-flops, the oscillator will control the flip-flop, and we've got our anti-lock solenoids wired to run 4 at a time. That way we won't draw as much amperage. And then we've got 2 leads for the pump. The pump will kick on when we throw the main power switch. So let's see if it works. Here's the finished product of the very first model. Forgive the spaghetti arrangement of the wires. Being the first model, it's just making sure that everything works. So we've got it hooked up to our little jumper pack, and it's plugged into the solenoid harness, and it's plugged into the motor harness. When we throw this switch, the motor should come on, and one of the half of the solenoids, so 4 of the solenoids will actuate. You want to hit this button right here. Hello, Mr. Button. Then it will still start to oscillate between these 4 and these 4, and with the motor continuously running. So let's put our crash helmets on. And all right, motor works. Yep. We'll let this run for a while and see if anything catches on fire. It's been a few minutes. Nothing's hot. Nothing's even warm. Yeah, it's nice and cool. Can't feel anything with the back of my hand. Back of your hand is a very cold surface on your body. So if you want to feel heat, use the back of your hand. Well, we've had it running for about 10 minutes. Nothing's hot. Fuses aren't blown. It's time to shut it off. So we'll hit this button. Kill it. That looks like a successful design, a successful test. Now let's put it on the truck and see how she does. Like and subscribe, or I'll set this fella loose in your garage.